Hello guys, this is Shayan. Welcome to new video from Bioorganic Hub. So in this video, we will also discuss a short questions, means 2 marks questions, which is important for IIT JAM. So this has appeared from JAM 2018. Actually, this is the year when I appeared for JAM exam and successfully admitted for IIT Kanpur. So this is about 1-2 versus 1,4 Grignard additions reactions. Means whenever you have a Grignard reagent like pH MgBr, you have a puzzle that which will be preferred more, 1,2 additions or 1,4 additions for a set of conjugated carbonyl compound. If you the reactant conjugated carbonyl compound like this, then obviously you have two choice which we will prefer. So the question was the reactant was like this was a conjugated carbonyl compound, and you have also a substitutions and oxygen atom. Now you have pH MgBr. So as you know, this is a Grignard reagent, so pH will act as pH minus and MgBr will act as a MgBr plus. So that is fine. Now pH minus is actually a nucleophile that you can understand. So that will create the additions reactions to carbonyl or this center. So there are two options. So if you have 1-2 additions, then obviously pH will react here. So you have O minus and attached with, and pH will be attached at this carbon atom. So you will have this pH, isn't? Our rest will be same. But if you have 1,4 additions, this is 1,2 addition because one pH means one nucleophile, it is going to be attached here, and O minus is 2 center. But for the 1,4 additions, pH will attack from the 1 positions for which 4 will be O minus MgBr. This is attack like this, isn't? So it will go like this, and O minus will be O minus MgBr. So that case the structure will be like this, isn't? You have a cyclohexane ring and the same O ET, this is fine, and you have a pH. Now this will be double bond and this will be O minus MgBr, isn't? So now you have to decide for these questions what will be the more favorable, 1-2 additions or 1-4 additions. Now this will go by hard soft interactions. pH minus is actually a hard nucleophile, you can understand, because you have too much pi conjugations in pH ring. That's why it will act as a hard nucleophile. Now in this case, C double bonded O will act as O del minus and C del plus, we all know. But for the case of the C double bonded C, there is no such case. So the positive charge at this carbon center is more for the carbonyl carbon functionality than a C double bond C. So this carbon atom is actually carries more positive charge. So this will act as hard electrophile, and you know hard like polar dissolves like polar, like the same principle. Hard likes hard and soft likes hard. So hard interactions will be more favorable. That's why in this case the reaction will go through 1-2 additions, not 1-4 additions. 1-2 additions will be right. Now we're going to answer. 1-2 additions will happen. So pH minus will attack here and this will go O minus. This will form O minus MgBr. Now on acidic workup it will just form OH. MgBr will go out OH. Now what will happen? You can understand. You have a OH. So OH in acidic condition, OH2 plus, and this will leave out. Now it will create a allylic carbocation here in this carbon, allylic carbocation. Now this allylic carbocation is stable because allylic carbocation has a conjugated situations. So now this will go there and this will stabilize this carbocation, so it will form this type of compound. This is just acid catalyzed conjugate pi bond associated removal of OH group as the H2O leaving group. This is H2O leaving group. So this will form this. Now you have water which is act as a nucleophile. This can attack here and can satisfy the positive charge of the oxygen atom. This will form OH as a removal product, and this will form this type of compound as a product. So the main principle you have to take home message you have to know for this reaction is actually the the answer is this, but you have to remember that this is pH minus, so hard nucleophile, so the reaction will go through 1:2 addition. That's all guys for this question.